Now we will solve a lab on SQL injection. So SQL injection is a technique that is commonly used to attack a web application that uses SQL database. It involves inserting malicious SQL code into a query to manipulate data, steal information, or even compromise the entire system. This report discusses the SQL injection vulnerability found in an API and provides recommendation for remediation. During the security assessment of the API, we found out that it was vulnerable to SQL injection attacks. Specifically, we were able to inject malicious SQL code into certain parameters of the API's request that were not properly sanitized. This allowed us to access sensitive data and even execute commands on the underlying database. We conducted a simple test to demonstrate the exploitability of this vulnerability. We crafted a malicious request by inserting a single quote character into a parameter, which is a common SQL injection technique. The API responded with a database error message that included the SQL query that was executed, confirming that the query was vulnerable to injection attacks. We then proceeded to inject more complex SQL code using union, queries, and subqueries to access additional data from the database. The SQL injection vulnerability in an API could have significant consequences if exploited by an attacker. It could lead to the exposure of sensitive information, including user credentials, personal information, or financial data. It would also result in the manipulation or destruction of data, as well as authorized access to other parts of the system. To remedy this vulnerability, we recommend the following action. Input validation and sanitization. The API should validate and sanitize all input data to prevent SQL injection attacks. This can be achieved by using prepared statements or parameterized queries, which separate the SQL code from the user input. Database access control. The API should limit the privilege of the database user account used by the API to the minimum required to perform its function. This includes limiting the ability to execute certain types of query and access sensitive data. Regular security assessment. The API should undergo regular security assessment to identify and remediate vulnerabilities, including SQL injection. This can help ensure that API remains secure over the time and that new vulnerabilities are not introduced. The SQL injection vulnerability in the API poses a significant risk to the security of the system. It is recommended that the API implement the above mentioned remediation action to prevent potential attacks by implementing proper input validation and sanitization. Limiting database access and conducting regular security assessment, the API can minimize the risk of SQL injection attacks and ensure the security of the program. Here is the application. Invoiceable is a SaaS-based invoice platform that enables businesses to issue invoices in all world currency and 29 languages. Alice, the CTO of Invoiceable, has engaged cybersecurity consultant Bob to perform regular penetration tests against the Invoiceable platform. Penetration testing, also called as pen testing or ethical hacking, is a practice of testing a computer system, network, or web application to find security vulnerabilities that would be attacker could exploit. As Bob, I will go ahead and load the Invoiceable web application in your browser using the following URL. Loading the links loads a password-protected web interface into the Bob's web browser. Browser attempting to log in into its test credentials, Bob button to analyze the HTML application source code. Reviewing the web application HTML source is a common technique used for mapping the application structure and reveal potentially useful information such as developer comments, hidden form fields, URL paths that may be otherwise not be visible in the browser. As Bob, go ahead and analyze the HTML source code of Invoiceable logins page. The developers have declared a form tag which is used to define the Invoiceable login web form. The login form further defines a set of input tags to collect the user's username and password. Finally, a submit event handler is declared, which invokes the login JavaScript method when user submits the login form. The login method invokes the function retrieve user IP address and assigns the return value to the variable IP address. A new HTTP post request is further initialized to send the user's submitted data to the backend API. The request values username, password, and IP address are being sent as a request body. The username and password values are queried from the login from while the IP address is obtained via an external call. Having reviewed the HTML code for the invoiceable login page, Bob begins his assignment by logging into the invoiceable website within the following test credentials. To understand how invoiceable login interface communicates with the backend server, Bob's intercept the HTTP request generated by a browser using an application web proxy. A web proxy, also known as HTTP proxy, is a software debugging tool that enables web developers to view and modify raw HTTP and HTTPS traffic between their machines and a remote web application. This may include HTTP, HTTPS request and response data, request parameters, headers, etc. Upon clicking the login button, Bob browser generates a post request passing username as a parameter with his email bob@livemail.com. Next, a password parameter password is sent along with Bob's password string password123. Bob further notices the post request passes a hidden parameter IP address. Before we continue testing the inversible application, let's further analyze how Bob's HTTP post request is handled by the inversible application to authenticate a user. Invisable developers have implemented the login method to handle user login process. The login method accepts username, password, and IP address parameters to be provided via the post request. It first checks whether the credentials are correct via the validate credentials method. If the credentials are valid, the method then checks if user's IP address is allow listed. To check this, a dynamic SQL statement is constructed by concatenating the IP address variable with a predefined SQL query. The dynamic SQL query is then executed on the database via the execute query method, checking if the provided IP address exists in the database. If such IP was found, the authentication session is set and retrieved user ID variable is returned via the HTTP response. Having analyzed the post request, Bob attempts to modify the IP address parameter by appending the IP address 192.13.73.77 with a single inverted code character. The final string should match the following input. Keep an eye on the code window as you modify the IP address parameter. We just have to add a tick and forward the HTTP request. See, interesting. Reviewing Bob HTTP proxy response, we can see that the JSON response object returns a SQL syntax error, which is usually caused when the SQL parser encounters an unexpected character. To further understand this error, let's look at the SQL query executed on the server side. Following the modification of the Bob's IP address with a single code character, the IP address string is directly concatenated with the SQL query without performing additional input validation checks against the IP address variable. However, since Bob's IP contains a single tick character, the additional trailing code is now unbalanced, resulting in a syntax error when the query is executed by the SQL engine. This ability to inject user supplied input, which is interpreted by the SQL engine, is known as SQL injection. In the previous step, Bob was able to inject a single quote with the IP address parameter, confirming that the invoiceable application is vulnerable to a SQL injection vulnerability. However, it is important to note that the modern web frameworks by default won't return detailed SQL error messages, which are needed by attackers to exploit SQL injection vulnerability. So, how can an attacker like Bob exploit SQL injection when verbose SQL errors are not configured on the remote web applications? However, open source tools exist to automate the exploitation of such SQL injection, which are also known as blind SQL injection. Since the attacker cannot view the response from the web server to assess with exploiting the invisible SQL injection vulnerability, Bob downloads a popular hacking tool called SQL Map, which he plans to use against the invisible web applications. SQL Map is an open source penetration testing tool that automates the process of detecting and exploring SQL injection flaws and taking over databases servers that are vulnerable to SQL injection vulnerabilities. As above, go ahead and launch the SQL Map tool against the invisible login API by issuing the following command. The following attack demonstrated is mock and not real. Additionally, some of the SQL Map tool outputs is removed for easier understanding and readability. Upon executing the SQL map, a warning banner is displayed to ensure that it is not running against a web application before getting approval by the relevant parties. Since Bob is an authorized penetration tester, he is okay to continue testing the inversible application. The SQL map tool has further been configured by Bob to inject the IP address parameter, which is vulnerable to SQL injection vulnerability. The SQL tool injects the SQL function sleep 5 via the IP address parameter, which forces the database to wait for a specific amount of time in seconds before responding. By injecting the sleep method, an HTTP response will be returned within a delay or returned immediately, allowing SQL map to infer if the injected query command true or false, even though the backend database is configured to not to respond to SQL errors. By using the sleep function, SQL map can rapidly enumerate and brute force remote database details, including database names, tables, and other sensitive data. In example, we can see that the SQL map has successfully identified the database name invoiceable master. Additionally, SQL map has identified several table names within invoiceable backend SQL server, which can further be enumerated to leak sensitive data, password hashes, etc. To further understand the root cause of a SQL injection vulnerability, let's take a look at the backend invoiceable source code. To recap, the login method extract the username, password, and IP address from the passed request body. It then checks if the credentials are valid and if the IP address is allowed listed. To validate the IP address, an SQL query string SQL is defined by concatenating the string IP address with the query string. However, note that no input validation is performed on the IP address string before including it in the final SQL query, allowing for malicious SQL queries to be injected and run on a backend database via IP address parameter, thereby making the application vulnerable to SQL injection. In order to effectively mitigate against SQL injection attacks, developer must use prepared statement, also known as parameterized queries, when building SQL queries based on user input. Prepared statement prevent SQL injection attacks by defining placeholder variables to safely pass parameters inside a SQL statement, which are automatically escaped at runtime. Let's see how a prepared statement can be applied to our vulnerable code example to remediate the SQL injection vulnerability. In our modified implementation, we first replace the IP address string in the SQL query SQL with a placeholder denoted by question mark symbol. Then we build a prepared statement which precompiles our query string SQL into a prepared statement object. Finally, we call the setString method to the prepared statement object to set the value of the placeholder question mark with the value of the IP address string. The setString method automatically escapes special characters such as inverted quotes by treating the input as a string literal and not as a part of SQL query, thereby ensuring that raw SQL queries cannot be injected via external parameters.